At this time of the year, I have days that I can take off from work. Today is one of them. There'll be a couple. I don't have that much leave that I can use like this, but definitely today. So it's early in the morning, and instead of making a video last night when I was really tired, which I always make all these videos, and you find folks probably don't know this when I'm tired, because it's the end of the day and that's when I can do it. But today it's bright and early and I can do this video. So I read a lot more in Nehari. I had already read all the way to chapter 2, but then now I finished half of chapter 5. Chapter 3, I'm sorry, chapter 3. I could have continued on this material, chapters 2, 3, and I believe also 4, are really Sept and Snyder done the Nehari way. And so it's a lot easier reading in here than it was for chapter 1. So if I show the book, chapter 1 really has turned out to be a bear, as I've mentioned before. Especially when I've tried to do problems. And when I show you the notebook, you will see that the word tried is what I did. So I went through as many problems as I could in chapter 1. But really, I'm missing a prerequisite. I know I'm missing a prerequisite to understand chapter 1 really well. Number 1. Number 2, it's an old book, and it's written in a very different style than modern books. It doesn't have nearly as many examples. And yeah, it assumes that by the time you land in this course, you already have a foundation in Fourier series that I, at this point, do not have, and a much more solid foundation of vector calculus that I currently do not have. And as part of the Baby Rudin Project, at some point down the line, there will be a vector calculus thing that I will have to do. Nevertheless, I did understand some of the problems. It's very interesting that some of the problems were either I have no idea what I'm doing, or this is super easy. One of the two. So yeah, so last time I left it off here, a problem that I was able to figure out. Oh, let me zoom out. I always forget to zoom out with these small books. Sorry about that. Okay, so I continued on with more problems having to do with what is really potential theory, for which I don't really have a book right now, and I'm not going to go and get one because I've got a bunch of other things that I want to do as well. I found a handout, and this handout has some really good examples. Started off on the maximum modulus principle, on which I'm going to make a video after this video going through all the complex analysis books that I have and working out how each book dealt with the maximum modulus principle, which is dealt with in chapter 1 of Nehari. And so this handout has some really good examples, made it real for me, and allowed me to understand how the theorem works. But now I understand how the theorem works a little better because I've gone through multiple books. But that's for the other video. Then I tried, I could see what I needed to do for setting up an integral that's actually a derivative, effectively. It's effectively a derivative. Or almost like a limit proof where it's f of x minus f of a absolute value modulus less than or equal to epsilon. So these are small values, and I could see what I needed to do, but it wasn't enough. And I tried pretty hard. I read a lot. I went back and I tried again to prove that the Poisson function, the harmonic function for Poisson is harmonic, and I did it again. I failed. I don't know. Someday I'll get this right. So this is all comeback material. Tried more problems, and I could see what I needed to do, but I was close, but no cigar in some of them. Then this one, I could see what I needed to do to show that you get the Cauchy-Riemann equations. Yes. And then, again, some problems were like, oh yeah, that's really easy. To show that the the Jacobian cannot be negative. Sure enough, you do the determinant, it's all squares. Got it. I think I got that right. Again, I wish the book had answers. That is a major problem with this book, in my opinion, and will be with other books that I try in the future that don't have answers, which I will be doing, for better or worse, usually for better. Then this annulus problem, I tried it. Yeah, no, I tried. And then I found this really nice handout for harmonic functions. And again, this chapter 1 of Nehari already satisfied my curiosity. I understand what Sept Snyder was saying now when he plopped his harmonic functions in some of the examples, or they, but yeah, I have to move on. And so I'm going to move on, and I read chapter 2. Of course, I'm halfway through chapter 3. And chapter 2 is just basic Sept Snyder early chapters. Just laying out the complex plane, laying out analytic functions, laying out the derivative, uniform convergence, all your basics. All your basics are laid out. And so this is all familiar. Going into power series, of course, this is something that I really like about Nehari. There's a lot more power series treatment. Very nice proofs that I understood. When I read them, I could see all the different things that were being done, and I didn't have to stop. It's like, yeah, I've seen this in Sept Snyder and have followed them step by step in Sept Snyder. So I love that chapter 2 was repeat material. And I'm looking forward to doing those problems. And because I've done some of those problems already and have the correct prerequisite, it's not going to be like chapter 1. So then I took some notes, and I'll make a video about this on the maximum modulus principle. So these are just here to show my progress, but I'm going to make a video specifically to these.